Hi, okay, we are doing an experiment. We are trying this live feature both on LinkedIn and YouTube. So let's give it a try. I thought that with this format, we can share a little more about the kind of daily challenges we are dealing with or topics that we encounter in our daily job. And one topic that is occurring again and again is how to validate a migration. So when someone is considering migrating, let's say, from COBOL to Java, one question they will have for sure is, okay, great. Once I got my Java code, how do I verify that this behaves exactly as the original COBOL code? That is very great question. Unfortunately, it is not as easy to answer, but we can answer that at multiple levels. One thing we can do is to verify that the migration is correct by construction in case we are using an algorithmic method. What do I mean by that? If we are translating code by implementing a series of rules, so for example, when I encounter an if statement in COBOL, I will produce an if statement in Java. So I verify that this rule behave correctly. I verify all the possible cases with and without an else branch, for example. And once I've done, I'm sure that this rule does what it's supposed to do. If I do the same for all the different rules that I employ to perform my transformation, my migration, then I can have some theoretical reassurance that my migration is correct by construction. And the interesting thing about this is that the effort to test this migration depends on the number of rules I have and not on the size of the code that I translate. So if I translate 1,000 lines or 100 million lines of code, doesn't matter. If the rules are correct, we assume that whatever is produced by this set of rules is correct, and therefore our migration is correct. This is a great theoretical argument, but no client seems to accept it. So they may be interested or require for their peace of mind another answer, a different answer. Now, ideally, we could say if we have a bunch of tests that we can run against the original code, let's say the COBOL code, they pass. We translate those and run those against the translated code base. So we translate both the original code and the original test into migrated code and migrated test. If the migrated test pass, they tell us that the translated code behave as the original code. This is in theory the idea. Now, there are a few problems with that. The big problem is that typically legacy code doesn't have tests. I think it's Michael Feathers in Working Effectively with Legacy Code that says legacy code is code without test as a way to define legacy code. And I think it makes a lot of sense because frequently, if you have an old code base, you don't have any tests for those. So this idea will work in theory. In practice, there are no tests to translate. So what can you do? Yes, you could write some test. The problem is that writing this test is quite an effort. So you can use this approach of writing tests manually for the legacy code, just so that we can translate later. But you can use that to cover maybe the most common paths in your code. It's typically not sustainable to write tests for the entirety of your code base, assuming you have zero tests. So going from zero to a reasonable code coverage is quite expensive. Okay, so another problem. So how can we solve that? Well, one thing that we are exploring is to generate tests to cover the legacy code base, verify the pass, then translate those and verify that also they pass also after the migration. So let's say we get a COBOL code base, we generate unit tests for COBOL, we ensure they pass, then we migrate the COBOL code and the COBOL test to get Java code and Java test. We run this Java test, they pass, great. We can consider the project completed successfully. That will be super nice. The problem is that it's very difficult. And if we were able to generate unit tests for this legacy code base, it would be useful in two different scenarios. These skills per se could be also useful in case you don't want to migrate, you just want to facilitate the maintenance of the original code base. Maybe after all, you decide that you are happy with COBOL, PL/SQL, SAS, whatever language you're using. You don't have tests. If we could generate them, that will be useful per se, also outside the context of migration. But also in the context of a migration, this approach to validate that the migration is correct has the important side effect of providing tests. Because if we generate tests for your COBOL code base, we translate them to Java tests, then you can maintain your Java code base more easily because you have tests that you wouldn't have otherwise. So generating tests that we could translate will be very, very valuable. The problem is that it's also very, very difficult. Why is this the case? Well, if we wanted to test, let's say, a procedure, we have a procedure, no matter in which language it is, we can consider it as a black box, and we want to translate into something else in Java, and we want that to behave in an equivalent way if we consider it as a black box. So if, for example, I pass to this procedure, function, whatever, some input parameters, I would expect to get a certain result. This model conceptually is simple, but there are a couple of things to consider. The first one is that the result produced, the inputs and the result produced by this procedure will not simply be the input parameters and the value returned to a return statement. In reality, this procedure could be affected by the external world because this procedure could read the data from a database, from a file, perform a network request, and so on. And as a side effect, it could also store data somewhere. So if we have to represent this procedure as a black box, we should see some different in values, the parameters, but also the tables of a database that it touched, the files that it touched, the network request that it produced, and as output value, not only the value returned directly, but also the tables on which you could write, the files on which you could write, and so on. But that means that we need to be able to study the code and identify what are these elements of the external worlds that have an impact on the value produced by the function or that are impacted by the function, so that we have a clear idea of the kind of things that we need to consider in our test. If we consider that the procedure that we want to test read the table of orders, for example, and produce as a result return to you some value, but it also write on the invoices table, then we need to figure that out. We need to figure that out by studying the code. Maybe this function call another function that call another one that read from the orders table. And so we have to be able to reconstruct all of this information, which is already quite some work. And once we have this information, we could then write a test of this type. Start the application, put this list of orders in the database, call this function with these input parameters, then assert that this function is returning a certain value, and assert that as a result of executing this function, I can find certain elements in the invoices table. Okay, so that will be my complete test. So we need to figure out the kind of elements that are affected by this function, both that are read or changed by this function, but we need also to figure out what kind of values to pass. Because perhaps this function has a behavior that is different when we have orders that have a value above 1 million euro. We need to figure that out by studying the code, and then we need to produce different tests, one that will try to insert orders below 1 million and one that will produce orders above 1 million. So we need to find all the different elements that are considered in this function, find all the relevant combinations, and then produce a certain amount of tests. Then we will also need to know what kind of values to expect, right? So for that, we could perhaps run the original system, record the results, and use those results that we have experienced in the real application to define our assertion. So at least that part could be done with a reasonable effort. But I think that this problem that will be very valuable to solve is an open problem. And so I think it will be interesting to see how research proceeds in this direction. We are doing our attempts in this direction, and we can confirm it's not an easy problem. And of course, one can produce some intermediate results. Perhaps one can identify what are the elements touched by a function and produce some documentation and produce a skeleton test, and then do a little bit of manual work to complete this test. This is not ideal, so this shouldn't be the end result, but that could be an intermediate step. So yes, there is nothing easy about migration, so it's a lot of fun, let's say. Probably I will be able to retire and have still see that in this field there are many problems open, but it's interesting to see what is happening in the area and what authors are doing, what is happening in the academy, what research is going on, and see what kind of solution we can adopt or develop and deliver a great answer to this very difficult question. So I hope this first live was okay, was not too terrible, and let's see if we are going to repeat this experiment. Thank you.